Preparing the human body for pregnancy requires the execution of two concurrent, structurally distinct cellular processes. The body must mature a single ovum, which is the biological egg, during the ovarian cycle. Simultaneously, it must build a highly vascularized, nutrient-rich environment for that egg to implant during the uterine cycle. These two distinct cycles are perfectly synchronized over an average 28-day period. To achieve this precision, both processes are governed by a single upstream controller. This master control network is the hypothalamic pituitary gonadal, or HPG, axis. The sequence begins in the brain. The hypothalamus acts as the initial trigger by releasing pulses of GnRH, or gonadotropin-releasing hormone, down to the pituitary gland. The pituitary translates this input by releasing two critical messengers, FSH, follicle-stimulating hormone, and LH, luteinizing hormone. These signals travel directly to the ovaries. The ovaries, in turn, produce estrogen and progesterone. These hormones act downward on the target tissue of the uterus. These five specific hormones, GnRH, FSH, LH, estrogen, and progesterone, are the chemical drivers of the reproductive timeline. The HPG axis uses these hormones to drive a continuous loop of alternating negative and positive feedback. This ensures absolute synchronization between egg development and uterine readiness. This timeline chart maps the 28-day sequence. Day 1 marks the beginning of the follicular phase. At this starting point, the anterior pituitary releases FSH into the bloodstream. FSH acts directly on the ovaries to stimulate the growth of multiple follicles. Follicles are small cellular sacs that contain and nourish immature eggs. As the cells within these specific follicles multiply and grow, they begin secreting their own hormone, estrogen. This creates a gradual rise in systemic estrogen levels over the first 2 weeks. Estrogen's primary target is the uterus. It initiates the proliferative phase, signaling the endometrial lining to regrow and restore its structural network. During this phase, the system operates entirely on biological negative feedback. The growing follicles intentionally produce low-level estrogen and a hormone called inhibin. These chemicals travel back to the brain to suppress the pituitary from releasing any more FSH. Dropping FSH levels starves the smaller, competing follicles of the stimulation they need. Only the single most dominant healthy follicle survives. Negative feedback prevents a runaway biological cascade, safely managing the slow, methodical buildup of the necessary biological infrastructure. By day 14, the cycle hits its midpoint and reaches a critical biological turning point. This line graph shows hormone concentration. The dominant follicle is massive, producing a concentrated amount of estrogen. Once estrogen crosses this specific threshold, the regulatory logic completely flips in an event called the feedback inversion. The system that was previously driven by negative feedback suddenly accelerates into a positive feedback loop. High estrogen now actively stimulates the brain. This inversion forces the anterior pituitary to dump its entirely stored reserves of luteinizing hormone into the blood. The result is this extreme hormonal spike, the LH surge. The LH surge is the direct, unavoidable mechanical trigger for ovulation. Under immense pressure, the dominant follicle sac physically ruptures, expelling the mature egg. The released ovum immediately transitions into the fallopian tube. The violently ruptured follicle casing is left behind, completely embedded in the wall of the ovary. The positive feedback loop acts as a physiological trigger. It transforms days of gradual chemical accumulation into an instantaneous, explosive physical event. The timeline immediately following ovulation is the luteal phase. The leftover ruptured casing undergoes a physical transformation, becoming a completely new cellular structure called the corpus luteum. This creates a temporary endocrine gland inside the ovary. Its primary biochemical function is secreting massive levels of progesterone. As this graph demonstrates, the systemic hormonal profile transforms entirely. A sweeping progesterone curve takes over the second half of the cycle. Progesterone has two vital roles. First, it drives the uterine cycle into the secretory phase. This phase maximizes the thickness of the endometrium. It establishes the complex vascular and glandular network required to physically accept a fertilized egg. Progesterone's second role is reinstating a massive wave of strict negative feedback on the hypothalamus. This chemically locks down further FSH and LH release. It entirely prevents any new follicles from developing while a potential pregnancy is in play. The corpus luteum acts as a system-wide lock. It halts new reproductive attempts while simultaneously perfecting the environment for the newly released egg. The maintenance of this delicate, high progesterone state depends entirely on the successful implantation of a fertilized embryo. If fertilization does not occur, the temporary corpus luteum reaches the end of its lifespan and begins to physically degenerate. As the gland dies off, hormone levels subsequently crash. Plummeting progesterone removes the structural support keeping the thick endometrial tissue alive. The starved tissue slocks off the uterine wall, initiating menstruation and officially wrapping the cycle back to day one. The sudden lack of progesterone also removes the negative feedback block on the hypothalamus. Without this block, GnRH and FSH levels immediately begin to rise again, instantly restarting the entire 28-day sequence. This self-regulating biochemical loop runs continuously for decades. It ceases only at menopause, when the ovaries exhaust their viable follicles and permanently lose sensitivity to the pituitary signals.